Hi students, today we will discuss magnetic effects of current part 6. Like that first to 5 parts no, I already did and already uploaded in the YouTube. Please go and watch that first 5 parts no, then come back to the 6th part so that you can understand very clearly. Okay, so in this part 6 we will discuss some more applications, the force between the two current carrying conductors. Already in the part 5 we already discussed, so the force between the two parallel current carrying conductors, that is two parallel current carrying conductors, what will happen now? They attract each other. Two anti-parallel current carrying conductors will repel each other. What is the force now? Mu naught by 2 pi into I1 I2 by d into L, right? So the same concept, same formula, we will use it. We will do some more applications here now. Let us do like one question here now. Suppose there is a one current carrying conductor is there. This is one current carrying conductor. Suppose I will take it as like a 10 ampere current is flowing onto this. Okay. So this is infinitely long current carrying conductor. Now I will keep one a square coil, right? A square coil of length, right? Of length, suppose it will be 10 centimeter length of this one now. It is also carrying a current in this direction now. Suppose current in this one is about 2 ampere, right? This is kept at suppose 10 centimeter from here. Now we want to calculate what will be the force acting on this square coil. Now we want to calculate it now. Simple thing, we already studied that two parallel current carrying conductors will attract each other. So you have to check it now, parallel and anti-parallel. So here what you can relate it now, here you can observe this is a current carrying conductor. Here this part of the current carrying conductor, both are parallel. Parallel means what will happen now? They will attract each other now. They will attract each other. This part will experience a force toward this side. Suppose it will be F1. Now therefore this part, this is an anti-parallel, because anti-parallel means what will happen now? They undergo like a repulsion force. This force, this part, it will undergo F2. Sir, what happened to this part now? See here, very simple one no. So this is our magnetic field here. The magnetic field inside this one no. This is a current magnetic field inside. This will be experiencing a upward force. And the same way, so here the magnetic field is there like this, right? So, but this magnetic field is not uniform no, because here very more is there. More magnetic field will be there, here less magnetic field will be there. So that what will happen now? Therefore force will be varies. On an average you can take one force now. This is a magnetic field, this side is a current, this side it will be the force. It will experience a force toward this side. The same way, therefore it is represented here now like this. So therefore here also the magnetic field will be, so the current is like this, magnetic field is like this, here like this. So same way, therefore magnetic field distribution is there, same current is flowing, same distance from this one now, this upward force and downward force, both are equal and opposite no, there will be net force along this direction no, it will be 0. So that's why, so here this one what will happen now? So here either this side or this side it will move. So which force is greater? So this F1 will be greater. Why? Because same current is there, but your distance is smaller. No, this force will be more, this force will be less. Total coil, no, it will be able to move toward this side. So we want to calculate the force acting on this square coil. It will be equal to, that is nothing but a F1 minus F2. Clear? So we have to calculate what is F1 now. We know F1. What is the formula? Mu naught by 2 pi, mu naught by 2 pi, currents are nothing but this current I1, I2, therefore current is nothing but here how much now? 10 into 2, distance between them is nothing but 10 centimeter, 10 into 10 to the power of minus 2, minus, so this distance no, mu naught by 2 pi into, therefore here 10 into, so 2, because this also 2 ampere, this is also 10 into 2 divided by, so therefore distance between them is how much now? This is 10, the length of this one is also 10, 20 centimeter, 20 into 10 to the power of minus 2. Clear? So we can write it as, here this 10 and 10 cancel here no. So here this 20 and 20 will get cancelled no. So we can rewrite it as mu naught by 2 pi, you can take it common. Not only 2 pi, 10 to the power of minus 2 also you can take it common. So 10 to the power of minus 2. So what is remain here now? This is 2. So mu naught by 2 pi into 10 to the power minus 2 minus 1. Clear? So therefore it will be 1 taken here, no. So mu naught by 2 pi into 100. So this mu naught by 2 pi is, mu naught value is how much, no? 4 pi into 10 to the power of minus 7 divided by 2 pi into 100. So this will get cancelled. 2 into this 2, it will go, no, 10 to the power of minus 5. So newtons. So will be the force will act on this square coil. Clear? So this is one of your NEET question, no. So be careful, no. You need, they will ask you how in which direction it is going to experience a force, or in which direction it will be able to move, either this side or this side. So we have to identify it now. That is your major question now, right? So go through this type of questions now. So very clearly. So now we'll go for one more application onto this one, no. So we'll see one more application, no. Therefore, so there is a one spring is there. So through this spring, what we are doing now, we are sending the current to this one now. Therefore, so what will happen to this spring? Therefore, the spring will compress or right, so expands, right, or remain same. We have to identify, right. So here what will happen now? Here this is nothing but one spiral springs are there, no. So that is nothing but current is flowing everywhere. That is one direction and another direction. Therefore here there is a one coil is there, another one more coil. Due to this one, no, the magnetic field is outward, and this also due to this one, no, the magnetic field will be outward onto this one, no. So therefore they are going to get attract each other now. Therefore, so they are going to get attract each other, because between these two means compulsory they will be going to compress onto this. Clear? Now one more application, no. Suppose here there is a one magnetic field is there, this is a magnetic field. In this one now, one current carrying coil we are going to keep it, one current carrying coil. So what is a current carrying coil now? Therefore here, no, this is one current carrying coil, this is a current, no, current is flowing through this one, no. It is in a random way. The length of this coil is L. Now what will happen to this coil? See, if you take one small part of this one, no, one small part, right, we'll take it as one small part of this one, no, the small part. What will happen now? Current is flowing like this, the magnetic field is, it is inside, magnetic field is inside. So therefore it will be experiencing a force in the upward direction. That is nothing but a dF, because small part, no, dF will be the force. Like that, another one more part you will take, no, exactly opposite. This is a current, this side is a magnetic field, it is experiencing a force in this direction. This is dF. Like that, each, right. So every part, no, it is expanding outward force, no. Therefore what will happen now? This part, so this this coil, so what will happen now? It will be try to expand uniformly in all the directions. So therefore what will happen now finally? So the finally it will become like a one circular ring. So then it will be stops here. Why? Because this is only the maximum thing, no, it can be able to expand. Therefore when a current carrying coil, you know, right, non-uniformly current carrying coil, no, in zigzag way, if it is keep in the magnetic field, what will happen now? Finally it will become like a one circle. So then afterwards, I mean a ring, circular ring, no, it will form and it will get a stop, because the further it will not able to generate. Here sometimes in our JEE Mains and IIT Advanced, no, sometimes they are asking what will be the tension developed in this one. No. What is the tension developed now? We will calculate the tension developed in this coil, no. We'll see now. How to calculate it now? We'll see. We'll take one small part of this, one small part, right? We'll take one small part of this one, no, one small part of this one, right? So I will draw it slightly bigger onto this so that you can understand very clearly. So this is one small part, a DL element, small part. This is DL element. Okay, small part I am taking, you know. So due to this one, no, this is your DL element, current is like this, magnetic field is like this. So due to this one, no, therefore it is experiencing a dF is a force. Due to this dF, so therefore this small part, no, it is making an angle of at the center of this one, no. So it is like a d theta, and this is your radius. So due to this force, no, what will happen now? It is developing one tension here. No? The tension we want to calculate it now. How to calculate the tension in this one now? Very simple one, no. That is, this is trying to get elongated, no. This is trying to push it out, this one, no. So it is experiencing one tension here, no. Let us assume the T. So this side is also tension T is there. Now we can split this one, no. Tension is like this. This is d theta means compulsory. So you can take it as like this one, no? This is d theta by 2, therefore this also d theta by 2, so this is also d theta by 2. So this tension, no, this tension what we will do, we will split this one, no, like this. So therefore here, so here now this side force, this is t cos theta, this side also t cos theta, and this t side theta. This side it will be get cancelled out. So this side force is balanced by this force, no. So we can rewrite it as this also d theta by 2, d theta by 2. So therefore you can write down t sine of d theta by 2. So this side is also t sine of d theta by 2. Clear? So these two directions, no. So these two t, this one, no, this one, and is balanced by this force, no. What you can write it now? You can simply, you can rewrite it as, so total downward forces and upward forces both are equal, no. Therefore here 2t sine of d theta by 2, it will be equal to upward force. What you can write it now? B into I into small amount of length is dl perpendicularly. Why? Magnetic field is downward and is into the board. So 90 degree onto this, right? So B into I into dl. Clear? So now here d theta is smaller, no? D theta is small. So we'll take it as, because we took it as smaller element, no? So sin theta, it will mean nothing but a sine of d theta by 2 will be nearly equal to d theta by 2. This is for smaller angles, no? Clear? So now let us see, we will substitute here, no? 2 into t into, therefore d theta by 2. So here b into I, dl element, no? This is totally formed like a circular path onto this. So this angle, you know, like you know that angle d theta is equals to theta. Theta is nothing but a length by arc length by radius of this, no? That is dl by r. Therefore dl is equals to r into d theta. Therefore r into d theta. So these two cancel here, no? Theta, d theta also cancel. Tension it will be equal to b into I into r. So if you don't know this radius of this one, no? Therefore we can rewrite it as total length of this. Total length of this coil, we know it, no? Length is equals to, that is nothing but a 2 pi into r. So like a circumference of this one, no? R is equal to L by 2 pi. So T is equals to B into I into L by 2 pi. So will be your answer, right? So this is one of your IIT advanced, no? This question has come. So try to observe this, no? So NEET level is not required, but JEE mains and NEET IIT compulsory. So this type of questions, no, you can expect it now, right? So let us see. Now we'll see one more application now, right? So one more application. Suppose here there is a one more application, no? Suppose there is a one current carrying conductor is there. This is I. Okay, one I1 is a current carrying conductor is there. So therefore what will happen now? One small amount of current carrying length is there. This is I2. So it is having length is L. These two are separated by, this is infinitely long and this is one small part of this. Therefore here this distance is, suppose it will be, suppose h, it will be your. Now what will happen now? So you try to observe, these two are parallel current carrying conductors. Parallel current carrying conductors means you should get into your mind, that is they are going to get attract each other. So therefore this it will be able to attract here, no? So with some force, that is what is the force we calculated, no? And this force is balancing by another one more force is nothing but a mg. Which one now? What is mg? This wire mass is there, no? Mg, downward force. So if this wire want to be remains at rest, no, or remains or freely floating, no, this downward force and upward force should be both are equal. Therefore force it will be equal to mg. This force it will be equal to, what is this one now? Mu naught by 2 pi into currents I1, I2. This distance is how much now? H into L. Correct? So if you are able to equate it, no? So whatever the question they are asking, what should be the mass, what should be the direction, what should be the current, all this one, no? They may ask you questions on this one. No? Clear? Right? So this is the currents or forces, no, can be balanced, so that this will be able to remains at rest, or it will be able to float in the air. So suppose if their currents are different, opposite in direction, this is not possible. Why? If the current is like this, therefore opposite current carrying conductors, so they will repel it, no? Therefore downward force it will be there, and mgl also is acting downward, so that it will be not able to in rest, no? It will be fall down with a greater force onto this. Clear? Now we will see one more application here, no? Suppose Now we'll go for one more application. No? Suppose this is an inclined plane is there. This one inclined plane. Inclined plane is there. Therefore, this is theta. Right? So here now there is a one current carrying conductor is there. This is one current carrying conductor. So therefore, current is coming out like this. Right? So like this one. This is one current carrying conductor placed in an inclined plane. Inclined plane. Right? Current is flowing like this. Now for this one now what you are going to do, we are going to apply the magnetic field is upward. So upward is a magnetic field. That means here this side it will be your current, this side it will be your upward force, it will be the magnetic field. What will be the force acting on this one? Now you have to use always Fleming's left hand rule. So this is your current and this side it will be a force. So this side it will be your, this side it will be your current, this side it will be your field, this side it will be your force. That means like this, you can see it now. Clear? So therefore, in which direction it is experiencing force? No. So this side it will be experiencing a force onto this. And therefore, downward force is there. No. What is the downward force? Because of due to this mg. So downward force it will be there. No. That is nothing but a mg sin theta. Right? So you might have seen so many times onto this. This is theta. This also theta. Sin mg sin theta. And this force is there. So what will happen now? Here is also theta here. No. So what you will get it now? You will be able to split it. No. So this is f cos theta, this side it will be the f sin theta, and this side it will be your mg cos theta, correct? Sometimes they may ask you what will be the normal reaction here, no? Normal reaction, what you can write it now? F sin theta plus mg cos theta. We don't want this normal reaction, no? We want, so this object will be either remains at rest or fall down with a uniform speed, right? Fall down with a uniform speed, or it should be remains onto this. That means what will happen now? Downward force should be equal to upward force. How much it will be? Mg sin theta is equals to f value. F value is how much now? B into I into L perpendicularly into cos theta, correct? So here, therefore here can write it now, B into, so I into L. So B into I into L taken here, no, that is nothing but a mg into tan theta. So most of the times B they ask, no, mg into tan theta by I into L, or they may ask you the current or whatever may be that, no, they may ask you, right? So this is one of your NEET question. NEET question now, right? So that's why magnetic effects of current no compulsory in JEE mains, compulsory in IIT advance, compulsory in the NEET examination. Minimum 2 questions you will get it now in the NEET JEE mains onto this, right? So that's why this chapter is more important. No, try to watch all these parts. No, like up to part 6 now we did. No, so like we'll have nearly some more parts also is possible onto this. So that also we will cover maximum content onto this. Right students, go through this sixth part. So go through thoroughly onto this. So we'll do some more parts onto this. Okay, right students, please subscribe to my channel. Thank you for watching.